Hi, I'm an old guy and I do maths. Today I want to discuss when a number is an outlier. We're dealing with numbers. I could say when a piece of data or data is an outlier, but we'll restrict this to numbers. We need to define what an outlier is. It's essentially a piece of data or data that looks like it doesn't belong. So a really clear example would be 1, 2, 3, 4, 5, 6, 7, 93. 93 is an odd participant in that set of numbers. But if we look at the sets of numbers that we've got here, which I have divided up into quartiles, as in I've taken a quarter of each set and separated them. You'll see why in a minute. Everything's the same except the last number. And what we're going to do is we're going to go through how you calculate an outlier, and that will allow us to say whether 15 or 19 are outliers, or if they're not, what number would be an outlier in one of these sets. So if we were drawing a box plot of this set of data here, this is badly drawn, but the median here would be 6 plus 7 divided by 2, so 6.5. That's the median. Q1 would be 3 plus 4 divided by 2, which is 3.5. Now, if this is mysterious, have a look at my video on medians or my video on box plots. The minimum would be 1 and the maximum would be 12. Oh, and Q3 would be 9 plus 10 divided by 2, which is 9.5. Okay, so it's fairly obvious, I hope, that there are no outliers here. Now, the only thing that changes with these other box plots is the maximum number. Everything else is the same. So the minimum is 1, the minimum is 1, Q1, the median, Q3, they're all the same. So what we're concerned with is we're concerned with these numbers here. And how we find whether something is an outlier is we calculate what's called a fence. And we can have an outlier at this end of the data or at this end of the data. It doesn't matter. So there are two possible fences beyond which an outlier would exist. Okay, so how do we find the lower one? Well, the lower fence is Q1 minus the interquartile range times 1.5. Now, the interquartile range is the difference between this value and this value. So in each of these cases, it is the difference between 9.5 and 3.5, which is 6. Sorry, that should say Q1 and lower. The upper fence is Q3 plus the interquartile range times 1.5. Okay. So we've got common values for all of the constituent parts of this calculation in each of these sets of data. And the only thing that changes is these two numbers. So we're going to work out whether one or both or neither of these is an outlier. And because they're at the upper end of the data, we're going to work out what the fence is for that. So Q3 is 9.5, which we worked out here. 9 plus 10 divided by 2 is Q3. The interquartile range, 9.5 minus 3.5, is 6 plus 6 times 1.5. So 1.5 of 6 is 9. So 9.5 plus 9 is our upper fence. That equals 18.5. Well, that's handy. So what it tells us is that this is not an outlier, but this is. And so if we were to draw a box plot of this graph really, really quickly and roughly, what it would look like without putting in the values again is it would look like this. And that's how we treat 19. And our fence is here at 18.5. Okay, so that's how we figure out what the upper fence is. Now, the lower fence doesn't matter because it's pretty obvious that this isn't an outlier, but just for the sake of completeness, I'll calculate it. So Q1 is 3.5, and it is minus the interquartile range, so minus 9. And that leaves us with negative 5.5, which is way down here somewhere. So the fence is down here somewhere. Okay. Right, so that's a very brief outline of what an outlier is and how we might calculate when an outlier exists or not. Now, the problem is when you have numbers like this. The problem is never when this number is 73 and this number is 84, or this number here is minus 20. That's obviously an outlier. The problem is when these numbers get close to the other numbers. And as you can see, it's surprising how high the fence was. I wasn't entirely sure whether this would be an outlier or not. I hoped it would be, but as it turns out it is. So that is outliers and how you calculate them. If there are questions that this raised, for instance, about what an interquartile range is, how you find the various quartiles in a set of data, or how you draw these box plots, have a look at my other videos in this playlist. All the information is there. Thanks very much for watching. See you next time.